Okay, so moving on, the expression formed by adding the terms of an arithmetic sequence is called an arithmetic series. And we talked about the previous lesson how series are different than sequences because your series are taking those sequence values and adding them up. You're finding the sum. The sum of the first n terms of the arithmetic series is notated by S sub n and can be found by using the following formula. So if you're trying to find the sum of a finite arithmetic series, this is what you would use. Okay, so the following formula is S sub n. That's how we notate your, not your rule, because obviously your rule would be A sub n, but your S sub n is your series. It's taking your n terms times A sub 1, your first term, plus A sub n, your highest term, divided by 2. So in other words, the sum of the first n terms of an arithmetic series, S sub n, is the mean or average of the first and nth terms multiplied by the number of terms. Okay, so let's look at our next example, example 4, as our last example for this lesson, and how we can use this to find the sum of your arithmetic series. So in example 4, we have a little bit of a real life story problem going on. They're asking us if we're stacking boxes in a warehouse. The bottom row, which is called row 1, has 47 boxes, and the top row, row 6, has 42 boxes. Each row has one less box than the row below it. Okay, so there's two ways that we could possibly do this, and I'm going to show you both ways because in this case it can be just as easy to draw it out as it would be to use the formula. However, if we were using many more terms, it may be easier to use the formula than it would be to draw it out. So I'm going to do both. I'm going to first draw it out, the situation, how we could use that drawing to get the final answer, as well as using the formula, because the formula will be useful to you down the road if you're looking at many terms that you're trying to add together. So let's try drawing this out. So obviously we have 6 rows total. The first row has 47 boxes, the sixth row has 42 boxes. So if I were to draw this, I know that I'm going to have 6 rows. So I'm going to draw this right here. So obviously this is going to be my first row. I have 47 boxes. The next row up, it's going to have a little bit less. We're going to have, what is that? One less box than the row below it, so this gives me 46. This is row 1, this is row 2, so we know we have 6 rows. Our third row is going to have 45. Our next row after that, which is row 4, has 44. Row 5, which we know will have 43, and just like it told us at the beginning, our sixth row has 42. How many boxes are in the stack? Well, we can clearly just add these all up. So 47 plus 46 plus 45 plus 44 plus 43 plus 42. If I add all of them up, I'll get the number of boxes that are in this whole stack. And if I do that, I get 267 boxes. Not too bad if I have to draw it out and I'm only looking at 6 rows and 6 sequence values that I'm adding up, or the 6 values in the series that I'm adding up to find the sum. Now we could also use the formula. I'm going to show you how to do that just momentarily, just because it's good to know how to use it in case down the road I have bigger, more than just 6 values. If I have 20 values or 100 values, I'm not going to want to draw them all out, so it makes more sense to do it this way. So if I do it this way using my original formula given on the other page, I take my first term plus my last term divided by 2 times the number of terms I have. So this would give me, well, the number of terms I have is 1, 2, 3, 4, 5, 6, or I know I have 1, 2, 3, 4, 5, 6 rows. So I know my n is going to be 6. So 6 times, well, my first term was 47, plus my last term was 42, all divided by 2. 47 plus 42 all divided by 2 gives me 44 and a half. 44 and a half times 6 gives me 267 boxes. So as you can see, we'll get the same answer either way. Obviously, there's a lot of benefit to knowing the formula and being able to use the formula, because you'll be able to use that for many terms that they're given to you. But we can always go back to drawing visuals with sequences and series, because that also helps. So that's just one way to think about it. So that's example 4. That concludes what we were talking about in lesson 2. What I'd like you to do now is work on Now You Tries number 6 through 9, and the next time we get together for class, you're going to also need to finish the checkpoints on the other page, numbers 1 through 6. So Now You Tries all the way from numbers 1 through 9 need to be due, and then the checkpoints for numbers 1 through 6 on the following page will also be due. So you have a total of 15 questions we're going to check the next time we all get together for class. So make sure you have that ready to go. You can always email me if you have questions. Otherwise, I will see you in class the next time we meet. And the last lesson that will be in this unit will be lesson 3.